let us look at the following logical expressions and check whether they are equivalent or check the validity of these logical expressions. For all x, p of x and q of x, is this same as for all x, p of x and for all x, q of x? Suppose in a logical argument an expression like this comes, can I replace this with this and vice versa? So we want to know, is this and this are equivalent? Okay, what we will do, we will make use of what we have discussed so far and try simplifying this. So in an attempt to prove this and this are equivalent, the first step is to convert this into a proportional logic by employing appropriate instantiation. So on ui, this becomes p of a and q of a for any a. Then this implies that I can write p of a for any a and q of a for any a. This a is applicable to both. Now I am associating with each of them so that there is a clarity when we simplify. So this becomes, so this and this are equivalent. Now p of a for any a, so perform universal generalization. Then this becomes for all x, p of x and for all x, q of x. So now this says that this and this are equivalent. So in a context, if this appears, you can replace that with this or vice versa. Now let's look at this. Suppose we have for all x, p of x or q of x. Is this equivalent to saying for all x, p of x or for all x, q of x? Okay. Now let's attempt a proof. So let's attempt a proof. So I perform universal instantiation. Then we get p of a or q of a for any a. So this you have to be careful. When you say it is true for any a, and over here this is and. So which means if this one is true, this is true and this is true. But over here it is or. If this expression is true for any a, for a specific a, if you look at it, so this statement is true. So there are possible things, right? P of a can be true and q of a can be false. Or this is false and this is true, or both are true. So there is a possibility that the entire expression is true, but this may be false for a particular a and this is true in that case. Or this is false and this is true. So I cannot conclude that p of a for any a or q of a for any a. So from this I cannot imply p of a for any a or q of a for any a. So this being true, it may be the case that this one is true and this one is false. So this one is false, this one is true, or both are true. So one cannot conclude that it is true for any A and it is true for any A. It may be the case that for a particular A, this one is true and this one is false. So saying this one is also true, it's not correct. One can establish a counter example. We will give a proper counter example to show that such an implication is not true always. Here is a counter example. So to establish a counter example, you fix one UOD, say set of numbers, okay, natural numbers. Now P of x says x is even. Q of x says x is an odd number. Now look at the left statement. For all x, P of x or Q of x. So what is this telling us? This says for each x belonging to UOD, x is even, or x is an even number, or x is an odd number, which is true. But look at the right hand side. Right hand side says for all x P of x, it says each x is even, which is false. Each x is not even. The next one says for all x Q of x, which means each x is an odd number, which is also false. So this shows that for all x P of x or Q of x, with respect to this example, this one is true, this one is true, whereas this one for all x P of x or for all x Q of x, this one is false for this example, this one is false for this example, therefore this OR is false for this example. This shows that true implies false. For this example, you see that each element in the universe of discourse is either an even number or an odd number, which is true. Each element is an even number, false. Each element is an odd number, is false. So this one is false. This shows that true implies false. Therefore, the forward direction or necessity is not true. When we attempted a proof, we saw that it is not implying this, and here is a counter example which says this implication is not true always. So this direction is not true, and so bi-equivalences is not true. Maybe the other direction is true. Let's experiment now. Let's look at the other direction. For all x P of x or for all x Q of x, does this imply for all x P of x or this? Okay. So this direction was false. We established a counter example. Let's verify whether this direction is true. So this being true, does this imply this? Suppose this one is true. Then what are the possibilities? For all x, P of x is true. This one may be true or false. But we know that this one is true or for all x, q of x is true. For all x, q of x is true. Okay, so case 1, for all x, p of x is true. Okay. Then independent of this, so what does that mean? This implies that p of first element is true, p of second element is true, and so on up to say p of xk, it is true. What is k? K is the cardinality of universal of discourse. K could be infinity also, and we can go all the way up to x infinity. For each of them, it is true. Correct? Since it is true for each of them, now from this I can write for each of them it is p of x or q of x. So it is true for x1. So look at this. So for all x, p of x or q of x, it is equivalent to writing p of x1 or q of x1, either this, and p of x2 or q of x2, and then next element, and so on. Since it is true for x1, x2, so on up to this, so this one is true, which means this expression is true. This one is true, therefore this expression is true. And we see that for each of them it is true, so one can conclude for all x, p of x or q of x. So this tells us that this direction is true. So for all x, p of x or for all x, q of x, and either this is true or this is true, and now if this being true, the possible values are p of x1 is true and p of x2 is true and p of x so on up to this. For each element in the universe of discourse it is true. Now independent of what q takes, what the truth value, what q takes, I can write this one as for all x, p of x or q of x. Reason, if you expand this, you get p of x1 or q of x1, and with respect to the second variable, with respect to the third variable, and so on. But we know that this being true, so this is true, therefore this is true, independent of what q of x1 takes. Whether it is true or false, this is true because this is true. Similarly, independent of what q of x2 takes, this expression is true. So we get true everywhere, and I can conclude this. Okay. So this is one, and one can also prove like this. So for all x, p of x, perform universal instantiation. So you get p of a for any a, or q of a for any a. Now for any a, this is true, and for any a, this one is true. Okay. Now from this we obtain this. As mentioned here, look at the truth values. Either this one is true or this one is true, and if this one is true, then perform generalization, meaning I can write this one as p of a or Q of A for any A. Now perform universal generalization. This becomes for all x P of x or Q of x. Or this may be true. Okay. Even if this one is true, independent of this, I can write P of A or Q of A for any A. Then perform universal generalization. We get for all x P of x or Q of x. So either you can prove like this is just by using the definition, or you can also attempt a proof by following universal instantiation, P of A for any A and Q of A for any A. Now this being true, either this one is true or this one, both can also be true, but it is enough if you consider one. If this one is true, then this can be rewritten as P of A or Q of A. This. One can also justify this. We know that P implies P or Q, this one as a tautology. You know P is true. Along with P, you can add any other variable. Whether this takes the value true or false, the entire expression is still true. That's really what we have done. Independent of what Q of A takes, the expression P of A or Q of A is true. Therefore, we conclude this. So, interesting part over here is, it is not biconditional, but it is conditional, meaning this implies this, whereas the converse is false. That converse is false. We are given a counter example, and the universe of discourse is natural numbers. Each number is even number or odd number, which is true, and this says each number is even or each number is odd, which is false.